Hey YouTube, welcome back to the channel. Today we're going to be talking about Kotlin Functions, and I'm going to share all the knowledge that I have, and we're going to get into some really cool stuff about Kotlin and how to use some of the nice features there. So let's jump into it and start a new project. So we'll do functions here and create that under Kotlin tutorials. I'll push this up to GitHub after we're done so that everybody can review it. All right. Let's jump into here and we'll create a new file called main.kt. No, I don't want to add it to Git. And we'll just create a new main function since it's a KT file and do the obligatory hello world. Make sure this runs for us. And we're good. All right, we have hello world. So let's create our first function. And as you can see from this above example, everything in Kotlin starts with fun. So create a new double function, which is going to double whatever the input is that we provide. So colon integer. So this is the type for our input. This is the name of it. This is the name of our function. And then this is the return type of that function. So here we'll say input times 2. And then if we call input up here with the value or input of 2, we should see 2. All right, and we do. Awesome. So another cool thing is we can do in IntelliJ converting to this expression body. And if our return statement is only one line, as we saw here, then we don't need to specify return and we can just set it to be an equal sign, which is really cool and moves all this up to be one line and makes it really succinct. Another improvement we could do is if Kotlin can evaluate what this return type is going to be, then we don't need to actually add in the return on the function specification. Don't do this if you want to have stricter types, but if you don't care about it, then we can just remove it. All right, let's run this again just to make sure that this all works as we expect it to, and it does. And let's create what's called a higher order function. And so this is going to be a function that either takes a function or a function that returns a function. So you can also have both, but that is the definition of what a higher order function is. So you can compose functions together to achieve something greater than what each of them individually could perform. So this can be, let's say we just want to get some next number, and we'll take our input. We'll take our input, which is an integer, and then we'll apply some custom logic to it. And that custom logic is going to be taking an integer and returning an integer. So what I'm gonna do is mirror this function double so we can use it in our custom logic. And then at the end of this, we are gonna return an integer. So if we return custom logic and pass it in the input, then that should get what we're trying to achieve. So we'll change this up here to call our next number function, pass in 3, and we need to pass it this custom logic, which for us, we want to use the double function. And so in order to pass that function reference, we need these colons in front of it. So there's 2 colons here. So what we expect is to see 2 and then 3 doubled. So we should see 6. So 2 and 6, or I'm sorry, 4 and 6. All right, that is a perfect example of what we were looking for. Now let's say we wanted to extend this further and we want to have something that uses this next number and maybe like add some logging around it. So we'll say next number with logging. And this isn't going to take anything, but it's going to return this syntax. So we could take this and put it down here, and then we want to change all this around so we can use our next number in here in this function. So this is going to take an integer and a function And then, yeah, we have it wrapped correctly. And then it's going to return an integer. So exactly this method signature up here. And we'll say print line about to call next number. And then we'll call using a function reference to next number. So, or actually, I'm sorry, we aren't calling it, we are returning a reference to the function. So here we will do next number with logging dot invoke, because we get the function back, but we want to call it, and we'll call it with this same information here. So we should see about to call next number and then 6 again. And we do. Perfect. So that's, again, this is a higher order function. This is a higher order function. Both of them are composing functions together to achieve something larger. All right. Another thing we can get into here is anonymous functions. And so if we didn't want to use a previously defined function, we can actually define our own custom logic. So we'll define an anonymous function, and this will have an input of an integer. And let's say we wanted to cap like the value of whatever we pass in to be 2, for example. We'll return an integer and we'll make it an expression body, and we'll say if input greater than 2, then we'll say 2. Otherwise, we'll just give you back whatever you passed us. All right, so from here, we can print line one of these. We'll do next number, and this time we'll give it 5. And we'll use our new custom logic here. What we expect to see is we're passing in 5 into this function, and we're going to get back 2 because we cap it. Should see 2 here as a return, and we do. All right, so if we didn't want to define this in a variable that we could then pass around, we could also define it in a lambda. And a lambda in Kotlin looks like this with these curly brackets, and it'll take whatever the input variable or whatever inputs are. If you didn't have any, it would be an empty parenthesis. And then let's say we want to add 4 to whatever we're passing in. So here we should see 4 as our output. Or I'm sorry, we should see 9. 5 plus 4 is 9. There we go. We see 9 there, and you can see IntelliJ is giving me some useful hints because the people who make IntelliJ also maintain Kotlin. So they want me to move the lambda argument out of the parentheses. So this is going to be really subtle, so pay attention. So did you see that? So what this did is instead of having the comma here, it let me have a parenthesis to close it and pass this as a block. Pass this lambda as a block because it's the last argument in our function call. I couldn't do this if this was the other way, but because it's the last one, then this works for us. So idiomatically, better to have any functions that you use at the end, so then you can use this syntax if you want. And we'll just run this, make sure that it still outputs 9, and that's what we see, which is good. If we wanted to increase our performance of, like, let's say this next number, did a bunch of custom logic here, and it was really bogging down our system, there is an overhead whenever we're using this next number function here. Whenever we're passing it in, I should say, we'll use this as an example, but it's really like any calls that are passed in. So it would be here in reality. So we could use inline to alleviate some of those performance hits, but you should really test this to make sure that it's beneficial to your specific application. It's not good to do this all over the place because a lot of times it just has worse performance than what you intended. So this is a tool you can use to get a little bit better performance because passing in these functions and passing them around does have a little bit of an overhead. All right, so that should all work the same and we should see all the same output, which we do. The next thing we can talk about is using infix functions. All right, so let's say we wanted to enhance our integer class. So we'll say smart int, and it's going to take an integer, call it target, And if we wanted to add some custom methods to it, like is greater than and is less than, these actually might already exist, so let's pretend that they don't. And we'll take another integer to compare against, and then we'll return target is greater than other. And we'll probably have to return a Boolean out of this for both of these. We'll do the same thing here. Other integer return target is less than other. All right, so now that we have our class, we'll do our smart int. It's gonna have a smart int, pass it in 5, and we can say print line smart int is greater than 4. And then our smart int is less than 6. So if we run this, we should see true for both. And we do. But there's a lot going on here. There's a lot of words, a lot of syntax, and Kotlin will actually let us do some cool stuff here. So if we did infix in front of both of these, then we can refactor this to say infix call, and you can see it eliminated a lot of those extra parentheses. So this is how, if you're doing like a for loop, then you say like I in some kind of a list. This is how some of this stuff works. So we can define our own infix functions and get some really awesome readability. So if we run this, we should see true and true again, which we do, and that's it. So that's another tool in our toolbox for doing infix functions. Now let's do some default and named arguments. So we've seen a little bit of this already, but let's talk about it explicitly. So we'll say we have this TV class, and it's going to have a volume attribute on it, and it's going to be 0. Let's say we have a volume up method so that we can turn up the TV. And this is going to take, let's say, an amount that we want to increase it. And then volume is going to plus equal amount. And that is the amount we're going to increase the volume each time. And this is where we can define a default. So let's say the default's always going to be 1. We don't want to jack up the volume too much if we don't pass it any values. So if we created a new TV, and I wish it was this easy to create new TVs. I'd have so many cool TVs. Then we could do volume here and do a volume up. And so we should see 0 and 1 output for this. And we do, which is excellent. Now, if we wanted to pass in our own value, let's say 5 for the volume, then we should see 0, 1, and 6 output. And we do. Awesome. So that's how you can see the default arguments. Let's say that we wanted to have a multiplier here. I don't know why you would do this, but let's say we had a super cool TV that would do this. Multiplier. So let's say we wanted to multiply whatever amount. You can see we don't have to change any of our implementation up here, but if we just wanted to adjust the multiplier, then we can use this named argument. Oops, if I spell it right. There we go. We can set the multiplier to be 5, and because we have a default for amount, we don't have to adjust it or pass it in or any of that. So what we should see is we saw 6 here, so 5 times 1, we should see 11 at the very end of it. And that's what we see. So there you go, some default and named arguments. Next, let's talk about one of the really interesting topics, which is reified types. That's kind of a crazy word, but let's say we wanted to check the type of a class and we didn't want to pass in a class. So let's say like check types, And you could pass in, you know, you'll see this in Java, like a Boolean class. So you could pass it in that way. But let's say we didn't want to do that. Like, we get this cool stuff here. So let's say we wanted to do Boolean here and not pass it in as an argument. Kotlin lets us do this by doing an inline function, and in these little brackets here, a reified generic, and we'll call our function check types like we did above. It's not going to take anything, and we'll just say we're checking the type of something. This is going to be really basic, so we're going to return when, and this is going to take t class, and then we'll have a bunch of statements checking for the different classes. So we'll check for a Boolean, let's say true. Again, this is like just an example so you can get off the ground here. And then let's say integer. So if it's not a Boolean, it's going to return false. And if it's an integer, it's going to return false as well. So we've defined this, and let's call it a few different times. And we will call it an integer, and then we'll call it a string. And this doesn't return anything, so we want a print line. And we'll run this. We should see true, false, false. And we do. So there you go. There's an example of doing reified types and giving you flexibility to really build your domain-specific language in Kotlin and give you all the tools to be able to do that. If you want to group all your functions into a certain thing, the best way to do that, let's say we have like a car and we want to change the oil and like change the tires or something. So we could have car object. This is just a really basic way to create a class, if you will, or like a grouping, because there's no namespaces in Kotlin. And so if you wanted to have change oil, and it's just gonna do a print line of change oil, and then we'll have another one for changing tires, maybe. Changing tires. There we go. And if we came up here, we could do car dot change oil, car dot change tires, and we should see those output because they're just doing print lines here. There you go. So that's a way to group your functions. This covers a lot of the function capabilities in Kotlin. And if you're interested in digging in more, there's a whole slew of other topics that are really interesting. Some of the things that we didn't cover are Lambdas. So you can go into no inlining. You can do cross inlining if you want to allow inlining in your function callers. So check that out if you're interested. And then also local and non-local returns within Lambdas. There's all kinds of different stuff you can do with flow control and doing different things with Lambdas. That's everything I had for today. If you like this video and you learned something, please like and subscribe, and I'll see you in the next one. Thanks.